Um, Before we get started, I am, really excited, as always, about this topic. Um, uh, the idea that we need to have a better understanding of what the air quality is, um, what is in our homes and the places we live, our buildings at large. We spend a lot of time on prescriptive measures, incorporating ventilation standards and protocols and filtration standards and protocols. But how do we really know, how this is working? And if we have a better understanding of our air quality, can we also save energy? So that's what I'm excited about to be talking about with you all today. Now, before we officially get started, I want to let you know we are launching our Giving Tuesday event. And this will be going on for the next month. We're doing our fundraising drive. So I hope you can go there and support our work and help keep these sessions going by heading over to our website, clicking donate, scanning this QR code here on your page as well, and helping us reach our Giving Tuesday goal, which is officially on December 3rd. And also a huge thanks to one of our sponsors, top tier sponsors, Build Equinox. Traditional energy recovery ventilators and HRVs provide basic ventilation, but often lack protection against airborne threats like seasonal flu and wildfire smoke. Introducing the SERV, an advanced indoor air quality management system. It offers energy recovery ventilation along with enhanced protection and intelligent air management. It's continuously monitoring CO2 and VOC levels, ensuring fresh air is only brought in when pollutants exceed healthy thresholds. It features high efficiency heat pump that recovers energy from exhausted air and preconditioning, as well as dehumidifying incoming air for comfort. It operates in a recirculation only mode, acting as a whole house air purifier while providing dehumidification up to 10 liters per day and supplemental heating and cooling. Has an optional UV light technology to sanitize the air add-on, and smart technology that keeps harmful wildfire smoke with optional VOC sensors for monitoring all air quality. You can visit buildequinox.com to learn more about this and the Serve 1000 for more institutional settings. All right, I want to welcome everyone to Navigating Indoor Air Quality Challenges with Saving Energy and Improving the Environment. This course is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. This course has not yet been approved, but submitted for multiple continuing education units. It is approved for our Certified Green Home Professional designation in health and energy, as well as submitted for AIA, health, welfare, and safety, which may make it applicable to your state-based design or contractor license. And it's submitted for FIAS, which will come to you later once we receive the approval for the code. So with that, I am super excited to hand it off to our speaker here today, Jim Carroll. Jim, glad you can join us. Please take it away.
Well, thank you, Brad. I appreciate it. I appreciate the opportunity. And obviously appreciate everyone joining today. I guess a little bit about our background and where we're from. Myself and the team at Sendel has been in the home control space better part of 25 years. Our latest venture here is really focused on healthy homes. And by that, we mean homes that are caring, that are comfortable, that provide a place for us to live in and be safe, primarily. Today, we're going to talk about indoor air quality and the impact of the green effort. You folks and a lot of other folks are out there building very healthy green homes from a perspective of protecting the environment, reducing the impact of the places we live in on the environment. But there is an underlying challenge and issue that all builders face, architects and major home renovations, and that's the issue of indoor air quality. My objective today is to provide you with some insight and some learnings and some things to think about and take away to see how You can change the way you build or design homes that are sustainable, not compromising on that at all, but also taking into consideration how do we understand how safe that environment is. In the last few years, we've gone to market with the product. We've yet to go into any home, any new home or existing home, instrumented with indoor air quality sensors, and find that 24/7, it's a clean and healthy environment. Um, so, in the walk away here, I'd like you all to be thinking about is what's the future look like? What are the emerging trends, technologies, innovation, and how can we influence building policy, building code to lead us to a healthier, cleaner environment that's also safe for the occupants? Now, clearly, homes today are high-performance homes are a complex set of multi-vendor, interrelated but seldom connected systems. These systems are both passive and active in their nature. By passive systems, I'm talking about the way we insulate homes, the type of windows we select, the type of insulation choices. Active systems in homes, there's many. HVAC systems, smart thermostats, fresh water systems, water heating systems. So there's a lot of technology in homes. The average US household actually has over 20 smart connected devices in them. But before we dive into this, let's touch on the awareness of indoor air quality and outdoor air quality that's really gripping the nation today. Hopefully you can hear this.
I thought, wow, this is even worse than I thought. That's what happens with our exhaled breath.
It may be the biggest takeaway from the pandemic. Our indoor air needs to be ventilated and filtered at a much higher level.
Think about the public health gains we've made over the past 100 years. Where has indoor air been in that conversation? It's totally forgotten about. And the pandemic showed what a glaring mistake that was.
Now, one comment I want to make on that, the gentleman from 60 Minutes talked about we're underventilating and underfiltering the spaces we live in. I think as a general point here, as we talk about ASHRAE, don't be concerned. You see the slide is standard out of ASHRAE. We're not going to take a deep dive here, but ASHRAE is very prescriptive on the amount of ventilation a home needs, and it's based on a methodology or practice, if you will, that's founded back at a time when there wasn't modern technologies. These building systems didn't exist the way they exist today, right? So this idea, and the bottom line here with ASHRAE, and this is the residential standard 62.2, which is adopted by the ICC National Code, which is further adopted by local regional code. So it makes its way through right down to local municipalities and how we interpret how much ventilation we need. But it's based on the square footage, the number of bedrooms, to determine just how much fresh air needs to be brought into a home every hour, right? And this is a gross misnomer, especially based on today's technologies. I'm going to talk a little bit about some field studies we were involved in that really highlights this. But what's important here is the ASHRAE standard today, really talking about, how do people feel in the home? Very subjective kind of standard. What does it mean? What does indoor air quality mean? And then the standard actually goes on in paragraph 2.2 to talk about how compliance with this standard does not necessarily mean you're going to get good indoor air quality. And that this research we've done on the homes that we're in, we see hour to hour, day to day, the level of indoor air quality can drastically change based on the behaviors in the home, as well as the outdoor environment, the climate, is there wildfire smoke. So all these things need to be taken into consideration. And this paragraph kind of calls out, hey, there's nothing we can do about that, so we're excluding it from the standard, right? We're not going to consider, the outdoor environment. We're not going to consider whether there's filtration, or the challenges that are created by bringing human beings into a space, right? And the activities of cooking, bathing, maybe smoking in a home, or having a gathering, a large group of people suddenly are in a home. This fixed equation goes right out the window at that point, right? And I'd forward that probably 80% of the time we're in our homes, the equation doesn't apply. So how many homes in the United States do we believe have poor indoor air quality? Um, the answer is any home with less than 7 air changes an hour, right? So it's if you go back to 2000, so over the last 24, 25 years now, we've seen the number of air changes per hour pretty significantly come down just with national code, right? So if you just build a home to code without trying, you're going to be down at 2.5 air changes an hour typically. I recently built a home on Cape Cod before we were all really into this and focused on this. I ended up with less than 2 air changes, and that was just to meet state code. Obviously, the net zero code homes are down under 3 air changes, and the folks at Fierce, um, they're seeing homes, less than a half, 0.06. So we're seeing a significant shift in how tight we're building homes, and this is all around, as you all know, around energy and conserving energy. The blue line in the background is the number of homes that were delivered over those years. So you see, it's a pretty significant population of homes that if we not addressing it, if we're not measuring the indoor air quality and not being proactive in our response to it, we get some pretty toxic environments that folks are living in. Now, what does this all mean? Well, I think it's on the energy side, it's very positive, right? Unfortunately, it's taken a conversation that's really should be focused on the 6 pillars that are associated with indoor air quality and made it about ventilation, right? And we talked to a lot of builders, a lot of architects, and they'll tell us, oh, that sounds interesting what you're doing, but we build the code and we've got ventilation, so we're okay. And the reality is that the compliance with an ASHRAE 62.2, we believe most of the time homes are over-ventilating, and we also believe that is a bad thing. But there is a period of time when we can be significantly under-ventilating as well. So why is over-ventilating bad? Well, particle matter, number one topic for us, and the World Health Organization identifies particle matter as one of the leading causes of death around the world. And actually, they had a report that during the first year of COVID, due to the lockdown, more people died from particle matter exposure than died from the COVID virus. So that's pretty significant, right? So particle matter, whether it's 1, 2.5, or 10, those are fine particles in the air. You think about car exhaust, the cigarette smoke, wildfire smoke outside. The environment I live in here on Cape Cod is on a golf course. Every morning, they attack the course with tractors, and they're cutting the lawn. You see the particle matter outdoors just climb and climb for the first hour and a half of the day, then it drops off suddenly, right? So it's very fluid and very dynamic. That example talks about the nature of the local environment and how that impacts your home. Also, humidity levels in a home, which is a big concern. High humidity is a really bad thing, but you know what? Low humidity can be a very bad thing as well. So ventilation, regardless of the type of equipment being used or the strategies being used, there's always going to be an impact. If it's 90% humidity outside and you're running nonstop ventilation, you're going to have a very high performing ERV or HRV, which is going to reduce that impact, but it doesn't bring it to zero. It's like, it's less than 1. It's like the potato chip commercial where they say less fat while they reduce 20% of it. It still got fat in it though, right? So very important point here. And also we've demonstrated that all ventilation will increase energy bills. And it's whether it's cold out, you're bringing, warmer air in than it is outside, but it's still not as warm as you want it to be. And the same on the cold side. So ventilation is a key point here.
So Jim, there was a comment here just, on the last thing you had mentioned about homes that have less than 7 air changes having poor air quality. So obviously the comment is, then do all our older homes that have terrible air exchanges have good air quality? I mean, I see you're kind of, maybe pointing that out in the overventilation, but can you just speak to that real quick?
Sure. Yeah, I think you're exactly right, Brett. By overventilating, by bringing in poor outdoor air quality, wildfire smoke's probably the best example of that, right? It's gone from something we heard about from time to time to being a real seasonal thing, right? And modern indoor air quality systems are aware of the outdoor environment. So as in my own home here, it stops ventilating when the outdoor pollutant matter gets to a level that it's going to contaminate the indoors. Um, Systems are also aware of, through data reporting, the level of carbon monoxide that's outside. There's a whole host of sulfur oxide, whole host of things that are bad for us, that if there's nobody home or if the house is lightly loaded with people, why would we bring in that outdoor air? Beyond the expense, the energy costs, we're going to bring in some percentage of pollutants. So the answer is no. I think, I'm a big advocate of that we should be as focused on existing homes and bringing them up to a new energy standard. And that's complicated, and we understand that. But we have to take measures to ensure that unfiltered, unconditioned air isn't just being brought into homes willy-nilly, right? It's absolutely critical. And really to emphasize that point, this data on the left-hand side is actually my home during an extreme wildfire event. It was here on Cape Cod. You can see the outdoor air quality got so bad with particle matter, but yet on the inside, it got to a yellow level because the system backed off ventilating just, just to ventilate. It waited until it absolutely needed to. And even at this point, it asked for permission. It pushed a notification to the homeowner saying, the outdoor air isn't great, but, indoor conditions are getting bad. Would you like to ventilate? And it will do it very stingently. That's the power of modern IoT technologies. So that outdoor awareness has nothing to do with any technology inside the home. It's just being aware of the environment and what's important and the quality of the air that is around us. Like my lawn cutting example, right? It could be dynamic. It's not going to be the same every day. It could be different time of day. These modern systems, control systems, need to be responsive to that. And this really starts leading us into, with this data, understanding what is the health impact associated with these different chemicals, whether it's formaldehyde, carbon monoxide. And we see a shift taking place where there's a lot of medical research that points to, as homes have become more energy efficient, especially in the States, we've seen earlier onset of childhood diseases, a broader spectrum, along with seniors, right? And both those populations spend considerably more time at home than, say, folks, teenagers to their 50s, right? Who tend to be out of the home a bigger percentage of the time. There was a medical doctor that explained it to us that a lot of these things, whether it's Alzheimer's or sleep apnea, they're DNA based. Their origin is part of who you are. And she put it as an example. She said, your DNA puts the disease bullet in the chamber. We think poor indoor air quality pulls the trigger prematurely. So it's really leading to this concept called the harm paradigm, which is focused on what's the exposure to these things, these different pollutants, and what does it do around early life deaths or poor health, the things that prevent us from living healthier, better, more fulfilled lifestyles, right? So it's these things are tightly coupled. That same doctor said, it's going to take a while before the government comes out and says, this is hazardous to your health. She pointed to cigarette smoking. Side of the package still says cigarette smoking may be hazardous to your health, right? So the correlation's there, but the causality still hasn't been tied out. But there's a lot of evidence and a lot of data pointing towards this being not a trend, but a reality, right? And the existence of high quality, low cost indoor air quality sensors is making this a real reality for all of us. To how can we measure, how can we understand, how can we take action to better improve our environment? So this idea of the harm paradigm has really been embraced by ASHRAE. I don't know, a lot of folks know Max Sherman. He's a fellow member at ASHRAE, PhD, and he's really digging down deep into this and advocating, and we're seeing it on the commercial side probably first, but I know he's very active on the residential side as well, that the old paradigm that's been around more than 100 years about ventilation rates per person is being displaced by this harm paradigm. How bad are these things, and what are they going to do to us? You know, when we talk about this with builders and architects, we often get asked the question, well, what does this mean to what I'm doing? If I was to step forward and started to address indoor air quality proactively, am I admitting that I've done things wrong in the past, even though I was to code? You know, am I opening myself up to liability and concerns around that? And I'm not a lawyer, but the answers we've gotten from folks is that it's relative to a legal term called standard of care. And that's if you're providing the level of care that's standard in the industry, whether it's building code or not, then you're okay, right? You know, the example always is the first car manufacturer that had seat belts didn't get sued for not having seat belts in the previous year. You're making an improvement, you're changing the standard of care to move forward. Now, there was some point when it was very aware to everybody that seat belts saved lives, that if you didn't put seat belts in, you couldn't sell cars, right? And if you put faulty seat belts in, you would be liable for, you know, if someone gets hurt due to poor performing safety measures. So I think that's where we're at this point is the standard of care, the awareness. We saw that 60 Minutes clip at the beginning. As a country, as a population, we're very worried about our health and well-being. And this is being brought to the forefront. And, you know, unfortunately, things like the wildfire smoke is really driving a big part of this. If you pick up a weather app on your phone, you turn on the local weather on the TV, they talk about outdoor air quality. They tell you, oh, today would be a good day to open your doors and windows, right? So the awareness level is increasing in a very broad-based way. Around the topic of, hey, I'm code compliant, I'm good, why would I do anything else, right? Well, if you look at ASHRAE 62.2 2010, you know, there is an opportunity to just use a continuous exhaust mode, 50 CFM bathroom fan, you know, based on the size and the space of the home. And we've tested a lot of homes that prescribe to this method. And the data on the right is actual data out of one of those homes where you see that the levels of particle matter and TVOC is pretty high. CO2 is not a contaminant. And there's a big debate about what do we know about this and is it really a pollutant? There is an emerging body of work saying that it does definitely affect things like sleep apnea, the quality of your sleep, your cognitive ability to perform. And, you know, again, it's going to be a while before we know that, hey, you know, high exposure to CO2 is going to have health issues. I think in modern systems, though, we use CO2 as a leading indicator. A lot of systems will use a sudden change in CO2 going up as, hey, let's get on the ventilation thing here, right? Let's make the assumption the population of a house has just grown significantly, right? Someone's having a dinner party or a birthday party or something. And we should now start proactively ventilating before we have a particle matter or TVOC problem or radon or something else is kicked in. So I think just the point here is just saying we're code compliant isn't enough, right? We collectively need to move this whole discussion forward in a way that takes care of people in their homes and, you know, aligns with our mission around a healthy environment, right? We're doing that so people are healthy. We got to close the loop here on this, and this is a critical way to do that. I want to shift now to a field study we did, and this was with a very forward-thinking builder. For those of you that I believe Mandalay Homes is part of the organization, but we kicked off a study with them. There was 3 identical homes in the same community on the same street, and by applying, it was already a good home, right? They build a high-quality home. But we did see that during high particle matter events, right, these homes in the high desert, particle matter could kick up, and we would see spikes on the indoor air quality relative to particle matter. You could see the house being overloaded with people. So you'd see shifts in this. But one of the big walkaways for us, and we talk about the ASHRAE standard, was these these homes had different demographics of people in them. One had a family of 5 with a pet. Second had a young, younger active couple working from home. So they were both working out of home offices. And their third was an active retired couple. And let me tell you, the ventilation rate requirement, the filtration requirements, the shifting levels of contaminants in those homes on an hour-to-hour, day-to-day basis varied drastically. And really for us drove home this whole idea that the number of bedrooms and square footage and all that really it's really talking about what I think should be a ventilation spec, that the home needs to have ventilation that's capable of this, so it can be applied when it needs to be applied to solve certain problems. But it really speaks to that point. And this field study showed us that we could reduce the ERV ventilation runtime by 71%, which resulted in a total home energy savings of over 12%. And for this study period compared to the previous year, it was in July, the average daily temperature was over 10 degrees warmer than it was the previous year, but yet the energy consumed to keep the house comfortable was reduced by 12%. That is the power of the Internet of Things. That's the power of abstracting away physical things, meaning that needing to have homeowners be aware and physically turn a switch off or engage a piece of equipment or manage their thermostat, replacing that with intelligent software and a control system. So this was done automatically. The homeowners in these scenarios didn't do anything but go about their day-to-day lives in a normal way, right? And the result was cleaner air, less energy being used. So very important point here. And we're showing that the home, the design. I know for you folks that are in this space, 0.75 air changes sounds high. I know you're typically down less than 0.05, but these are high quality homes. Dave and the crew out there, they do a phenomenal job with these products. And this is part of that same case study. And it really, we worked with some third-party engineering, mechanical engineering companies to get underneath how would a prescriptive solution look versus a code compliant, right? I mean, performance versus prescriptive. So a performance-based system, we kind of changed the way we think about things, right? And we're showing the calculations from these homes, showing what the average outdoor temperature was, high performance, ERV was in the middle, the psychometric impact of that, the amount of energy. On the right-hand side, we start talking about runtime to condition ventilated air, right? So a runtime calculation, proving out the energy savings we thought we saw, right? And we compared this with an energy monitoring system that was in the home with the Arizona Public Service, the actual bill for the home. And the calculation is done based on the psychometric calculations for the load of the home, right? The BTUs and the actual power being consumed to maintain the outcome that the people in the home felt was comfortable and safe, right? So this is really now shifting to a performance-based home versus from just a prescribed home, because these homes, the code said these ERVs should be running 24/7, right? So that's what ASHRAE called for. That's what the building code called for. But we demonstrated here collectively high quality built home delivering high quality results based on performance versus a set outcome. Now, I touched earlier on the 6 pillars of indoor air quality, and 2 of these pillars, you as architects and builders have direct responsibility for, right? And they tend to be static. And I'm talking about the building enclosure itself, the building practices, the methodologies, the design of the buildings to limit or eliminate infiltration, the materials being selected, the type of glues, the type of woods, the paints, all those type of things. The second part of the second bullet is something the homeowners are responsible for. But I would like to believe that as architects and builders, we would start providing some of this education to homeowners, right? About, California's got standards around rugs and fabrics and furniture for low VOCs and impacts and really what that means, and air fresheners and things like that. I think if we're going to build high quality homes and we're going to focus on pollutant source awareness, equipping homes with indoor air quality sensors, it's also incumbent upon us to make sure people know and make informed decisions around how they furnish homes, both from, how they're heating them, the source of fuels, whether it's electric or natural gas or oil, and how that's all going to impact when we're cooking, all those elements. Pollutant source awareness, I think this is the big topic, right? It's seeing the invisible. And there's a lot of pushback here. As we look at indoor air quality sensors, there's a lot of certification that goes to some of these things, but there's also some snake oil products out there, right? So we have to be very aware. We have to be good consumers. And today, the solutions that are out there to be affordable measure a lot of things like particle matter, TVOCs, radon, humidity, temperature. But there's also some other things that are very hazardous to us, like formaldehyde and sulfur oxide and other things that just aren't practical to put in every home, to measure those things. And you get pushback from building scientists, from equipment manufacturers saying, well, if you can't measure it all, we should just stay with the standard. But I think we've proven to ourselves at this point that the standard's good. It's foundationally, every home should be able to deliver filtration, ventilation, and humidity control based on some performance, right? But we still need to be aware of when to engage these things and to the level that we need to engage them. And we're only going to get there with pollutant source awareness. So absolutely critical. And I think we have to be comfortable to shift off a 100-year-old way of thinking about what is indoor air quality to, well, let's measure the things we can. Let's respond to those things, because these other things we worry about, we know they're a direct cause of, like we talked about, overventilating, underfiltration, building homes with, subpar filtration systems in them. And, almost the redheaded stepchild a lot is humidity control. Those Mandalay homes, some of those homeowners put humidification in because their average daily humidity level is very low. And we saw homes improve from high 30 to 40% humidity levels up to 50% humidity. And people reported they felt more comfortable. It may or may not impacted reduced energy consumption for the heating and cooling of those spaces, being a little more humid. So it's very, very important. And we also see that controlling humidity, environments where a lot of folks will open their doors and windows in the morning, and it could be humid out but cool. And then as the day warms up, they close the house up, the AC comes on, the dehumidifiers come on. And as the furniture and the wood and those things start drying out, all of a sudden they report the VOC levels go right through the roof, right? And along with particle matter. Because as these things dry, we're creating aerosols, and the contaminants that may be on the surfaces, that may be in the fabrics, become airborne. And now all of a sudden we've got this situation, we're chasing our tail a little bit. Would we have been better off keeping the home closed up and letting these advanced systems do their job and deliver cleaner environments? And it's really when we talk about the 6 pillars, we got to really be focused on the 4 dynamic elements of that, right? Because I mentioned on the top that the homes are a set of complex systems. They're seldom interrelated or connected. Filtration, ventilation, humidity. You see some advanced thermostats try to help with that, but you almost need a PhD in psychometrics to figure out really what you're after, right? I don't think the average homeowner knows when they turn the heat on or off, the AC up and down, or set a humidity level, really what we're getting to there, right? What is the desired outcome? It goes well beyond comfort, right? And I can't emphasize enough the need for pollutant source awareness. And that's really, we're talking about the indoor activities, cooking, bathing, the number of people in the home and what's going on in the home, as well as those outdoor pollutants, right? We got to keep our eye on that, as well as the climate, how we apply filtration. These modern systems are smart enough to go into a filtration mode only or a ventilation mode only, right? Or being totally aware that if we're going to ventilate, let's simultaneous filter, because the outdoor condition may not be optimal, maybe suboptimal. So let's get on top of it. Let's stay ahead of it and start filtering as we ventilate, right? And be deliberate about when we ventilate. Let's pick and choose the right time of day, day a week. And if nobody's home, let's not ventilate at all, right? These systems are smart enough, especially with things like geofencing on your phone, to know that, hey, person's, someone that lives in that home is 4 miles away. We're marginal right now in the indoor air quality. Let's ventilate, let's filter, so you walk into a clean, healthy home, right? It may have saved 10, 12 hours when you were away from any of that activity taking place, which saves energy, saves wear and tear of the equipment, saves the need to, or reduce the need to change filters so often, right? So this all starts sounding very complicated. A lot of people are probably thinking to themselves, wow, what does this take? This is a lot. And the answer is it doesn't take much, right? The add-on lift for indoor air quality solutions that are in the market today are pretty light in the grand scheme of things. Continuous source monitoring, there's outdoor air quality solutions. The EPA's got one that a lot of systems tie into. There's inexpensive energy monitoring to be added to homes, smart thermostats. We're seeing indoor air quality monitoring happen in thermostats and in smoke detectors today, right? And then you need the solution to be in the middle, the software that's smart enough, intelligent enough to say, okay, we see something going on the left-hand side here. Let's go take action. And these actions are delivered through things that are already in the home. I mentioned on the top that average US household has 20 smart devices in it. A lot of these solutions just leverage that smart technology, smart light switches and outlets, smart thermostats to engage balanced ventilation, dehumidification, power dampers, fresh air makeup, filtration, right? So this isn't like, a world to come. This is the here and now. The technology's there, the pieces and parts are there. I really believe we really need to shift the discussion to say what best fits our solution. How do we implement these things? How do we provide the education and the awareness to the end consumers? And let's try to do it in a way that we don't scare the heck out of everybody, right? It's, this isn't like selling a home security system where you see the ad, the young lady sitting on the couch with her children, some bad guy breaks the window, right? Oh my God, everyone's, but we have to be honest with ourselves and with the people we're selling homes to about, the risks that is associated with high performance, high energy conservation homes, and the environments that we live in. We've talked to a number of insurance companies about health insurance and home insurance, about, instrumented homes, homes that have proactive control systems in them. And if there's an opportunity, both from the health and from home insurance, that they could save money, reduce claims, they would obviously step up and reduce the insurance. We also think there's tax credits that should exist for high performance homes that are performance based, right? Intelligent home controls, you tell I'm pretty passionate about this. This isn't complicated. This is smart technology, smart softwares being applied, because the average person doesn't want to be a facilities manager. They don't even know where to begin, right? So these systems need to be simple and easy. They need to be inexpensive, and they need to be added to all homes, right? And make people aware of what's potentially possible, what else they could do to improve their overall performance in their home environment. I think the opportunity here is from your perspective, from high value homes, is to drive these requirements or these needs to homeowners. It will help them step up and say, I'm willing to spend this money, right? So today, we're going to be real with ourselves. All these high performance homes and homes with good indoor air quality systems being applied to them, they're really high end homes, right? They're out of the reach for, entry level homes and things, but it doesn't need to be. And I think as we go through the acceptance and the uptake in a broader sense in the broader market, it will bring, these technologies to a much bigger market. Potentially every home, every dwelling in the country will lower the cost for the high performance builders as well. So there's a big element here that's economically driven, but I think we can overcome it. Because again, in the grand scheme of things, this isn't a big expense. In many cases, the most expensive element of it, the ERVs or the fresh air systems, they're already there. We're just talking about making them better, making them perform better, save energy, keep people safe, right? So it's really gets back to, I think really what this webinar is about and what the organization is about. It's about education and advocacy, right? We all have to play a role in this. We all have to play a part in this. We can't just, make this something we look at and say, oh yeah, that's important, and then walk away and not do anything about it. We need to embrace it. If anybody's got any questions, I can be reached through email. Invite you to visit our webpage. If you go under the HVAC contractor part, there's a lot of information on the webpage about our particular solution called Breathe, as it works across a wide, broad set of strategies and approaches from ducted to unducted systems, hydronic systems, very inexpensive approaches, as well as pretty elaborate system approaches. That's really what I had for you today. I want to turn it back to Brad, or I don't know if there's any questions as we went through this.
Yeah, Jim, thanks so much. And there are some questions, and we have some time to get to more questions. And before those questions come in, real quick reminder that yes, this session is being recorded. You can rewatch it, catch it anytime. You can check our YouTube channel in the next couple days. You'll see it there, or you can go there to subscribe, get the notifications, and then you'll receive an update when it is available. For those of you watching this in the future, but not right now on demand, make sure to take your quiz with an 80% passing rate to receive your CEUs. For those of you here today, you'll get your certificates from certs at gutenbergcerts.com. As long as you've been here the whole time with the name you want printed on your certificate, check your spam for that. And make sure you take that survey that pops up at the end as well to receive that. And before we get into all of those questions, again, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our nearly 400 members. We're almost there. I hope you can help us hit that goal by the end of the year. And our top tier sponsors who help us do this work, such as Rheem with decarbonization for water heating, Build Equinox for demand controlled ventilation, Panasonic, Mitsubishi Climate, and all of them who support our work. So yeah, Jim, the specific question that came in was about heat pumps, air source heat pumps. And it was kind of a 2-in-1 question. So the first part of the question was kind of just distinguishing within this conversation about the level of MERV filtration. But then they were kind of asking that in the context of heat pumps, and maybe they were doing that because obviously mini splits come with deficient filtration levels. So, maybe their question was, speak a little bit to the level of MERV, and then also what we do when we're dealing with, systems like mini splits or even radiant that don't typically have any or minimal filtration in them.
Okay, sure, yeah. Well, there's a couple of approaches there, right? First, MERV 13 is what we've seen is probably the best minimum that should exist, right? And it's and as we work with HVAC contractors doing system designs, let's just start there, right? Let's not start having a discussion about static pressure later and things like that. But there are a number of products. One of our sponsors makes a great ERV that also provides filtration. So if you've got mini splits or you've got which mini splits, I think most I've seen have a MERV 8 filter. Filters are there to protect the equipment, not the people, right? Which, by the way, generally speaking, that's the role of a filter in an HVAC system traditionally, is to protect the equipment, not the people. We've changed that. We're shifting that thinking into, let's take care of the people in the home with these filtration systems. The other thing I want to touch on is an emerging group of indoor filtration systems, air purifiers, right? That some are starting to get smart. We've had discussions with a number of manufacturers that are looking to connect to our platform to allow us to engage those things. When I make a comment like that, everybody that's in this field is going to be able to do this, right? There's nothing unique about this to us. But I think that's important. And the level of filtration will vary depending on the home size, the number of systems you may need. But it's absolutely critical. But again, there's also other ways to get around the challenge of filtration when we're using heat pumps and mini splits and things like that. But it's a great question, and we get that all the time. Brett, you're muted.
Yep, thank you. The other question that came in was just considerations of, outdoor air quality and, maybe speaking a little bit to more how you're handling that. I think in their case, they were talking about, heavy truck traffic, diesel traffic, and I might even want to add to that a little bit if I think about the ozone. What's being done with sensing ozone, and is there anything we can even do about that, or is that just then an immediate, we need to shut everything down?
Well, I think there's a couple of questions there, really. The outdoor air quality, there's a lot of crowdsourcing going on in that space. A, a large number of golf courses have these lightning detection systems built right into those things, are outdoor air quality, right? So we see a network of this. The EPA's got a great app where they network together a lot of sensors right around your community. I think it's called Air Now. And just taking a quick, Air Now. I'd recommend you download that. You can put your zip code. It will tell you what the outdoor air quality is around your home. There's also outdoor air quality products that you could buy that will also inform you very specifically about your backyard, that your neighbor's barbecue is actually producing bad air quality, right? But the other question was, there are things like ozone and other things that we have no direct control over. But again, if you've got an intelligent system and it says, hey, the indoor air quality is fine right now, we're going to shut it off because the ozone's gone through the roof, the nitrous oxide or particle, whatever it may be, right? And these systems are very sensitive. And I've seen that. I use the example of my own home living on a golf course. I see it real time. I hear the tractors in the morning. I see the particle matter going up, and I see our system respond. So these things are pretty sensitive, right? And it's crowdsourcing. So there's communities that have systems. There's individuals that will put an outdoor air quality sensor on their own home and then publish the data to the cloud, so it can get sourced by all these different apps. So whether it's a weather app, WeatherBug or Air Now, they're all reporting outdoor air quality. They're doing a pretty good job of where it is geographically around you.
The other question that came in here, I guess, is just speaking to some of the trade-offs of, sealing up our homes or relying on, mechanical ventilation and filtration. And, when we speak about health at Green Home Institute, we, include more things than air quality. And I really liked that slide you showed on the ASHRAE, where they basically relented to the fact that there's other health attributes that they just can't control for: light, sound, mental health issues, maybe. But we like to think through that. We want to be able to benefit all health aspects of a home. And so the question, I think, from the audience here was, some of that trade-off of, losing that connection to nature versus being in sort of this sealed home with, mechanical ventilation. Is that something you've thought through or considered at all?
Well, I think it's one of those risk reward type of things, right?
Yeah.
It's We can't control the outdoor environment. It's going to be what it is. Are we diligently going to be monitoring it all the time to make sure it's optimal for my use? Or are we going to count on automated systems to do that for us? And if you're going to count on these systems, my advice is make the home as tight as possible, put good quality products in place, and let the systems take care of things, right? And it's because we're not all going to do this, right? I remember when I first built this house, and we were talking about this. It was first bad wildfire season. It was coming down from Canada. My HVAC contractor sent me an email. You should shut off your ERV. I never got an email to turn it back on. Right? And we're just not going to think about that day to day. We're not facilities managers, right? So I think the risk reward there is very good. The air you're breathing is going to be cleaner. I'm not advocating everybody just stay home, right? And where we live here in Cape Cod, I'll be honest, every morning I open the doors and windows, and around 9:30, 10 o'clock, I say it's time to close it up. But now I'm paying attention to it.
Yeah.
Right. And
well, and that's a good point. And that was, the other thought I had was, if you have informed information, if you have data on your energy use and your air quality, it should be giving you a sense that now is an okay time to open a window, right?
That's right.
So then you get that connection to nature, right? So you're still going to control that, right? You're not going to get a letter that says, shut your window, open your window. You're going to do that. But a lot of people, I think, do that not knowing whether it's, okay. Maybe you'll feel the humidity outside or the heat or whatever.
Right.
But now you'll get a real sense of, hey, does it kind of say, hey, now's a good time to really crack that window open? And then it will give you the feedback on what happens, right?
That's right. And if it's just readily available to you, you're going to take advantage of it, right? And it works both ways. Intelligent systems. I know I'm not supposed to talk about my product, but one of my daughters had an event here where she had a bunch of women over, and we couldn't keep up, right? They're drinking wine, they're cooking, and over Sonos system, it said, hey, you reached your indoor air quality set point. We recommend you open doors and windows. Before it told them to do that, it checked the outside to make sure the outside was actually better than the inside.
Right.
Right. And it's kind of what you advocate is maybe systems should do the opposite thing too, right? You get up in the morning, maybe your phone should say, today's a good morning to open the doors and windows, right?
Yeah.
We don't think of it that way, but that for everybody, that'd be a great product enhancement, right? Hey, today's a good day. And then maybe push your notice, maybe now's time to start thinking about closing it up, right?
Right. Yeah. So when you're talking about these types of systems, are you primarily talking just about, ventilation or humidity control and filtration, or are you also talking about air purification? So the actual idea that, something is in the air that, or UV light or whatever it might be, something that's actually killing viruses and something that's making claims that it can, attach to VOCs and break them down. Are you speaking to air purification or seeing that at all?
We've spoken to manufacturers of that equipment. It's difficult because I can't tell you if COVID's in the air, so I can't tell you if it did anything to fix it, right? Whereas with these other sensors, I can say, here's a problem, here's a response, right? And the software can get smart enough that it knows, typically in the morning, these things, it can proactively start doing things based on previous performance. I don't know if COVID's in the air. So I can't tell you if the UV thing did anything. So I don't have a closed loop there, right? And I think that's true with all the products in this space.
Right. Let's talk a little bit about some different pollutants real quick. The first one I'm thinking of is, when we measure VOCs, it's not, of course, telling us what the VOC is. There's obviously, like you had mentioned, you're cooking, you cut open a fruit, you have a drink, it can spike the VOCs, but those are fine. But obviously something like formaldehyde, is there an effort to distinguish some of the nastier VOCs from the ones that are safe, so we really know if we've got to get rid of that?
There really is. I mentioned manufacturers. There's a lot we have insight to and how they're trying to tease that apart. One of the products we work with, the TVOCs, red wine's a great driver of TVOCs.
Right.
Now, can we, somehow separate that out and not have the system go tilt because you just opened a couple of bottles of red wine, right? It's just So I think there's a lot of work being done, a lot of research being done, and a lot of
Yeah.
great product innovation on the sensors, the type of sensors and how they're being used, and how that data is being applied, right?
Mhm.
Um,
Uh, Yeah, and what about so this question kind of came from I think a home electrification coach. So clearly, if you're trying to help someone with electrification and make a case, we've got a lot of PM 2.5 sensors we can use, looking at the things that output that. But what about sensors for like NO2, which I know is one of the nastier gas stove emissions that can't be ventilated very well. Is there an effort to kind of track those kinds of things, or is this really more of a, hey, if you want to have this good air quality, we really need to also shift towards electrification?
I think the latter is true. The the type of sensors we're starting to talk about get very, very expensive, right? And
Yeah.
then it becomes a discussion around if we know activities like dehumidifying a house from 75% down to 50% is going to create VOCs or potentially, aerosols like formaldehyde are cooking. Let's just start ventilating and assume they're there. And let's take
Mhm.
steps, right? The cost to make those discrete measurements, and some of it's not even practical. Some of the measurement of those type of things is a process where you collect the air for a period of time. You pull a sample out, you bring it to a lab, and you test it. It's just you can't. There's no like dynamic in home, or the way we can measure particle matter or the VOC stuff, right?
Yeah.
But
Yeah.
we can clearly draw correlations between changes in humidity level, pressure, temperature, activities. This could result in that, so let's assume it is, and we'll go try to
Yeah.
do something about it, right?
Yeah. Now, what about mold and mildew? I mean, is that something that's directly being measured, or is this more like, like I've got multiple sensors around my house that give me mold risk indicators. One is
Right.
like high, low, medium. The other one is like a 1 through 10 rating. And so it's, if I understand mold risk, it's really, temperature, humidity, and time. And so are these systems kind of just monitoring more like risk and saying, hey, there's this risk, we need to adjust it, or is there opportunity to actually monitor spores in the air at all?
Well, I think the answer is yes to both of those. The systems in place today are doing exactly what you do. It's an algorithm,
Yeah.
right? How wet is it, humid, your temperature, how long has it been, what's your probability, right? Uh, it probably, I think a couple of months ago now, I had a college professor reach out to me. He's got a couple of students that have come up with a spores measurement product
Hmm.
that could and actually distinguish between black mold and white mold.
Oh,
So they're
wow.
grad students, they've got working prototypes, and
Yeah.
they were talking to me about how do we get this to the market? Who are the people we should be talking to? How valuable do you think this is, right? Where would these units go, right? And
Right.
how do we manage that? The other side of that equation, though, Brett, is let's also be smart about managing humidity in our home, right? Uh, there's all these intelligent systems. The systems that tell us water turned on, right? I have a system in my home that says master shower just turned on. Let's take steps right now. Let's push dry, dehumidified air into that space before the mirrors steam. And right? And we're also exhausting, and let's not over exhaust because
Sure.
I can't dehumidify the outdoor air, right? So if my wife
Right.
opens a window after showering, we don't have a sensor that says, oh, it's high humidity here. It's just going to keep going. It's just going to run,
Right.
run, run, right? So there's got to be other logic there that proactively tries to take the algorithm part of it and say, this could
Yeah.
result in something. Let's go do something about it. And it could be
Yeah.
as simple as like an inducted system, turn it on the fan mode to associated zones, right?
Mhm.
Like my master suite, my living room, and all that's on the same return.
Mhm.
Turn the fan mode on for both. All of a sudden, 10 times more air than what's in the bathroom can be mixed and lower the overall humidity level.
Yeah.
That's a low wattage event. It just takes a little bit of intelligence and coordination, right?
Yeah.
People aren't going to do that. People aren't going to, I'm going to go take a shower. Let me turn on the fan mode, these things, turn on you want time to take a shower, you jump in the shower, right?
Right.
It's
Right. Yeah. Well, Jim, it's 1 o'clock. We're at our time, and I don't see any other questions. So I guess, can you just again remind everyone where they can go to reach out to you or learn more?
Sure. Yeah. www.sendal, SENDAL.io.
Yeah.
And I'm Jim Carroll, which is jcarroll@sendle.io. I'd love to hear from you. Any questions, concerns, anything I can do to help forward this initiative. We're here. And Brett, thank you very much for this opportunity. I really appreciate it.
Yeah, I'm really glad you joined us here, Jim. And I follow Jim up on LinkedIn too, and hear all sorts of great things you post and learn from him there. So make sure to reach out to you and get connected with Jim on LinkedIn as well. So take care, everyone. And Jim, thank you so much. We'll catch you all next Wednesday and Thursday. There's some different events, so you'll see that coming from me later. So take care, all. Bye.
I know.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.